Okay, so boys, we're starting a new topic today, and this topic is back in your Year 9 textbook. So you can just go to box of books for any of the work that we're doing on this topic. And our new topic is trigonometry. It's a major Year 9 topic that we do. This gets built on next year and into Year 11 and 12. So regardless of what level that you do in Year 11 and 12, you will need trigonometry. So we're learning the basics of it now. So trigonometry is the study of triangles. The triangles are everywhere. So we really need people to understand triangles. So anybody going into building, anything to do with roof structures, trying to make sure that things are square. If you look back at even the Greek buildings that they did way back in ancient historical times, they knew about triangles. Okay, Pythagoras was a Greek. He discovered Pythagoras' theorem because it was a need for it. Okay, so you already know about Pythagoras' theorem and how that works in right-angled triangles, and we're going to build on that a bit more with trigonometry. So when we do Pythagoras' theorem, it's all about a right-angled triangle and finding the length of a side when you know the other two sides. But what we're building on now is also dealing with the angles in a right-angled triangle. So this whole topic of trigonometry has two parts to it. In Year 9, we do the right-angled triangle trigonometry, and in Year 10, we will build on that and do other triangles that are not right-angled. So firstly, we have to understand what we're going to call these sides in the right-angled triangle, otherwise none of it's going to make any sense. So at the moment you already know what a hypotenuse is from Pythagoras' theorem. It's the side opposite the right angle, and it also is the longest side in the triangle. If we look at any other angle apart from the right angle, so if I look at this one here and call this theta, then I'm going to call the side opposite that angle the opposite side. So it makes sense. So just get your red pen, draw that in, straight across from that angle, and that's the opposite side. It's opposite the angle I've given you here. Now the other side is called the adjacent side. Remember that adjacent means next to. The house adjacent to yours is the one next door to you. All right, it's next to you. So this angle, this side here, the adjacent side, is next to this angle. Now you might say, well, so is that, but that's already got a name, hasn't it? All right, so we're trying to find, it's easiest to look at the hypotenuse first because you know it's opposite the right angle. The opposite side next because you know it's opposite the angle I give you. And the one that's left with nothing on it is the adjacent side. And if you look at it, it is next to that angle. All right, so we're going to do some examples. I'm just practicing the naming of these things. So in this first one, for the marked angle, which is the one I've coloured in, we're going to name the hypotenuse opposite and adjacent sides. So in this one here, the hypotenuse we know is opposite the right angle, so 13 is our hypotenuse. Then when we do our opposite side, we go opposite that marked angle, and that will be your opposite side. I'm just going to write an O there for opposite. So the opposite side says 12. Now the side you haven't used yet, the 5, that's the adjacent side, and it's next to your angle. Okay, so we look at the next one here. Here's your marked angle. Our hypotenuse we're going to do first, opposite your right angle. So this is our hypotenuse. We are going to name it, so we need to call it the two letters on the end of that. So it's SR, or the other way around if you like. Then we're going to do the opposite side to this angle, straight across, and name it. It's TR, or if you like, RT. And the one that we haven't done anything with yet, which is this one, has to be your adjacent side. So that's TS or ST. Okay, coming over to number 2. We're looking at triangle LKM in this diagram here, and we are going to name an angle. Make sure you underline that in red what we're doing. We're naming an angle. When we name an angle, we use the angle symbol and we use 3 letters to name the angle. So we want to go opposite the hypotenuse. Well, that's your hypotenuse because that's opposite the right angle. So the angle opposite that would be the actual right angle, and And if we name it, 3 letters around it, it's MKL or LKM, whatever you like. Make sure the L is in the middle. Okay, the next one, opposite side LK. Here's side LK. If we go opposite it, we're pointing at this angle up here. Name it, LMK, or the other way around, KML. Make sure your M is in the middle. Now the next one says we're looking at the adjacent side. Be careful with these things. The one next to side KM. So here's KM, and we want the angle next to it. Now it's not going to be the right angle because it's never the right angle. It's this one up here. So it's LMK or KML, and there it is. Make sure the M's in the middle. And the last one, again, we're adjacent next to side LK. Here's side LK. We want the adjacent angle. And if you're not sure with the adjacent ones, just have a look at what other angles you've got. It's not going to be the right angle. It's not going to be that one over there because that's opposite it. We want the adjacent one. So it'll be the one that's left, which is this one, angle MLK or KLM. Make sure the L's in the middle. Okay, looking at the next one. Now we've got another couple of Greek letters here. We always use Greek letters to be naming angles, or not always, but quite often. So theta is one that we use a lot. Theta. Alright, that's this one up here. Gets used all the time. This is an extra one we've just thrown in for these questions. It's phi. Alright, it's a circle with a line going straight through it, sort of vertically or on a slight angle. So we're finding the opposite sides for angles theta and phi. So firstly, opposite theta, we want the opposite side to angle theta. So there's theta. Opposite that is the side EF. Next one, opposite angle phi, straight across, the side DE. Or ED, doesn't matter which way around, as long as you've got both letters there though. Alright, the next one, we're looking at this triangle and we're finding the adjacent sides for theta and phi. So adjacent to theta, well it's not this one because that's the hypotenuse. It's not this one because that's opposite it. So it must be this side here, HI. If we look at phi, we're looking for the adjacent side. It's not this one because it's the hypotenuse. It's not this one because that's opposite phi. So it must be this one, IJ. Now, the next question is number 5. All right, now it says triangle ABC has hypotenuse AB and side AC is opposite angle theta. Draw the triangle. So you just draw it and look at it later and just check if it's all okay. So we're going to draw a right angle triangle up. Now we know it's ABC, but at the moment we're not sure where the A, the B and the C are going. Then it tells you the hypotenuse is AB. Okay? So we'll put the hypotenuse on, AB. Then it says side AC is opposite angle theta. Well, this has to be C because there's nowhere else for it to go. Side AC is opposite angle theta. And that's your triangle drawn. So we need to be really good at this for building on the rest of this topic, but you shouldn't have found that too difficult at this stage.